I am Anil Kumar. Welcome to our special series on trigonometry. It is specially designed for students beginning to learn concepts about trigonometry and build upon these concepts to be masters. Here we'll discuss 5 examples based on reciprocal trigonometric identities. Based on what you have learned till now, we'll solve these questions. Join Anil Kumar classes. Enjoy the journey of success. You can always contact me on the email address given. Let us now begin. How do we solve or prove these identities? I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have 5 questions. These are related to trigonometric identities. In each identity, we have reciprocal ratios involved, or you can say secondary trigonometric identities. You can pause the video, answer these questions, and then look into my suggestions. In case you want to learn from me, you can send an email on the address given. The questions before you are: secant theta equals to cos theta plus sin theta tan theta, cosecant theta times cosecant theta minus sin theta plus sin theta minus cos theta divided by sin theta plus cotangent theta equals to cosecant square theta. Cot theta over secant theta equals to cosecant theta minus sin theta. Secant theta minus 1 divided by cos theta minus 1 is minus secant theta. Tan theta divided by 1 plus secant theta plus 1 plus secant theta divided by tan theta is 2 cosecant theta. So these questions are from beginner's level to expert levels. I should say this is a difficult question, right? Let me write this as a difficult question as compared to the above questions, right? So treat this as a quiz. It will help all students who are beginning to learn reciprocal ratios. To begin with, let us recall some formulae based on trigonometric identities. We know quotient identity, which is tan theta is sine over cosine theta, cot theta is cos theta over sine theta. The reciprocal identities are cosecant theta is 1 over sine theta, secant theta is 1 over cos theta, cotangent is reciprocal of tangent. We'll also look into even and odd identities. Sine of minus theta is minus sine theta, cos of minus theta is plus cos theta. Tan of minus theta is minus tan theta. So cos is even function. And sine and tangent are odd functions. Right? So these are important to look into for the purpose of solving these questions, plus the Pythagorean identities. Sine square theta plus cos square theta is 1. 1 plus tan square theta is secant square theta. 1 plus cotangent square theta is cosecant square theta. So we are going to use these identities in this particular example, right? So you should review this before getting into the details. So I hope that is clear. Let's move on and see how do we answer question number 1. The idea of this is all students who are beginning to learn how do we prove identities, it is a lesson for them, right? So it is a lesson to understand these strategies. So our idea is to understand simple approach. To prove these identities, right? So the very first is secant theta equals to cos theta plus sin theta tan theta. So here we see that the right hand side is more complicated. It can be solved or simplified. So we begin with the right hand side since it is more complicated. And that right hand side is given to us is cos theta plus sine theta tan theta. The idea here is to write down all the ratios in terms of sine and cosine. So we know from the quotient identity that tan theta is the ratio of sine theta and cosine theta. So we can replace tan theta with this particular ratio. And then what do we get? You can actually pause the video and do it with me. We get cos theta plus sine theta times tangent theta written as sine theta over cos theta. Now at this case, we can now simplify this as fractions, correct? So remember the concepts of fractions. Take common denominator and then simplify. Common denominator here is cos theta. So cos theta becomes the common denominator, cross multiply cos square theta plus sine square theta. Now you know the Pythagorean identity, which is cos square theta plus sine square theta is 1, right? You can use this identity to further simplify, and what you get here is 1 over cos theta. And 1 over cos theta is known as secant theta. That is the reciprocal identity, correct? So we now applied the reciprocal identity. So you understand all these steps involved in solving or proving such identities. And we begin from one side and prove that it is equal to the other side. In this case, we began from right hand side and we showed that it is equal to the left hand side. That is what we mean when we say trigonometric identities to prove trigonometric identities. Is that clear to you? Well, in case you want to learn from me, you can always send an email on the address given. So let's take up the second example. I hope this is absolutely clear, right? Now, second example here is slightly more complicated. In fact, I will say it's kind of a review of what you have learned. So I hope you remember. So the question here is cosecant theta times cosecant theta minus sine theta plus sine theta minus cos theta over sine theta plus cotangent theta equals to cosecant square theta. Well, this time we'll begin with the left hand side since it is more complicated. So you always begin with the side which is more complicated. So let's write it down. We have cosecant theta times cosecant theta minus sine theta plus sine theta minus cos theta over sine theta plus cotangent theta. So we'll write all of these in terms of sine and cosine. So first step is write them in terms of sine and cosine. Cosecant is reciprocal of sine. So we'll write this as 1 over sine theta. So this is also 1 over sine theta minus sine theta plus this term is already in sine theta and cos theta. So sine theta minus cos theta over sine theta. Cotangent is cos theta over sine theta. Correct? You see sine theta is common in all. So I can take 1 over sine theta as common. Now, in rest of the terms, what we can do? Well, this particular term here, I would write this as 1 minus sine square theta. Let's take this inside term now. Here we have sine theta in the denominator, and we get 1 minus sine square theta. Correct? Since we took sine theta common, so these terms have sine theta in denominator. Let me write this as sine theta minus cos theta plus cos theta. Correct? Now, you can clearly see that we have 1 over sine theta, and within the bracket, I could write each term as 1 over sine theta, and this is minus sine square theta over sine theta is sine theta, plus sine theta, minus cos theta, plus cos theta, correct? Now, as you can see, that is 0, and this is also 0. So basically, we have written 1 over sine theta times 1 over sine theta. So I could write this now as equal to 1 over sine square theta. And 1 over sine square theta is cosecant square theta. And that is how we can say it is equal to the right hand side. Is that clear to you? So that could be a way of solving or proving this identity. Remember, there are more than one ways to solve any question. So you can approach it differently, but you'll get a similar answer. I hope this is absolutely clear. If you have any questions, you can always send an email to my address here. I'll be glad to answer all your questions. Here is question number 3. Now, I hope at this stage you have learned a lot of concepts. And so, you should be in a position to pause the video and answer these questions. In fact, question 3 and 4 is for you to practice. So, the purpose of putting this is kind of a practice question for you. Anyway, here is my solution. Now, in this particular case, you could begin from either the left side or the right side. It all depends on you. You can select any side, right? So, let us say we want to do with the right hand side, which is cosecant theta minus sine theta, right? We could do that. Or on the left hand side, we have both reciprocal identities, may be a good idea. So let me begin with the left hand side this time. And what do we get? We have cotangent theta over secant theta. Now this could be written as cot is cos theta over sine theta. See how I am writing, right? Times secant is in the denominator. I could write this as 1 over cos theta. You get the idea? 1 over cos theta. Now we can see we have cos square theta in the numerator divided by sine theta in the denominator. You can see that we need a difference here. So that guide you to write sine cos square theta as 1 minus sine square theta. And we have sine theta in the denominator. So this we get from the Pythagorean identity, right? You remember? So let me write down Pythagorean identity just to show you how we got this step, right? We know cos square theta plus sine square theta is 1. So from here, we could isolate cos square theta, and we can write cos square theta as 1 minus sine square theta, correct? That is what we did. Now let's continue. So we have 1 over sine theta minus sine square theta over sine theta. Now 1 over sine theta is reciprocal and is equal to cosecant theta, and sine square theta divided by sine theta is sine theta. And that is what is required, and that is on the right hand side. So once you show that left hand side is equal to right hand side, you have done your proving identity procedure. Perfect. So that is how you'll do it. Well, you could have started from right hand side. In that case, the result would have been kind of going in this direction, right? you will reach the same left hand side. So I hope this concept is absolutely clear. Now, let's take up question number 4. Now, this is a thinking question at this time. So you have to think about how do we get this solution? Well, clearly, we have to begin with the left hand side. Since we have secant theta, it could be written as 1 over cos. So let's begin with the left hand side. And what we have here is secant theta minus 1 over cos theta minus 1, right? Now, secant theta can be written as 1 over cos theta minus 1 over cos theta minus 1. And that gives you 3 layers of fractions. Cos theta 1 minus cos theta over cos theta minus 1. So you see, we have 1 minus cos theta and cos theta minus 1. So we can flip, right? So we can write this as 1 minus cos theta over cos theta. And the other expression here could be written as, we can take minus common, right? And we can write this as 1 minus cos theta. And then we can cancel these. You get the idea? And then we have our result, which is 1 over, with a negative sign, since this is the negative sign here, 1 over cos theta. And this is equal to minus secant theta, which is equal to the right hand side. You get the idea. So in this particular question, I think the critical step is, how do we write cos theta minus 1 as minus of 1 minus cos theta? So see, you can flip it, right, with a negative sign, and that will give you the required negative sign on the right hand side. Perfect. So that is the way of solving this particular question. Now, we come to a challenge question. So this question is a very difficult question. So I would like you to really understand how do we solve this question. So I'd like you to pause the video and try this out. So it is a bonus question for you. We have tan theta over 1 plus secant theta, 1 plus secant theta over tan theta equals to 2 cosecant theta. Well, the idea is similar to what we have been looking into. Write them as sine and cosine. We'll definitely begin with the left hand side, since that is more complicated. So starting with the left hand side, what do we get? We have tan theta over 1 plus secant theta plus 1 plus secant theta over tan theta. Writing them as sine and cos, we could write this as equal to tan theta is sine theta over cos theta. See, I'm writing like this, sine theta over cos theta times 1 over, this expression is 1 plus 1 over cos theta. Does it make sense to you, right? Similarly, I'm writing here as 1 plus 1 over cos theta over tan theta is sine theta over cos theta. Right. Now see, if I multiply this with cos theta, this cos theta on this side get cancelled. So we have sine theta in the numerator. Denominator, we have to multiply both these terms, right, with cos theta. So we get cos theta plus 1. This is very important step, right? Now here also, I'm multiplying with cos theta, so I get cos theta plus 1 divided by this cos theta and that cos theta, which is a common denominator, cancels. So we get sine theta here. I would like you to understand this particular logic, correct? So what is happening here is we are taking the common denominator and then we get this result, right? And now we can take common denominator of sine theta times cos theta plus 1, cross multiply and get a result. So this is equal to, we are taking a common denominator, that is how we work with fractions, cos theta plus 1 times sine theta. And here we get sine square theta plus cos theta plus 1 whole square, right? So if you expand, what do you get in the numerator? We get sine square theta plus cos square theta plus 2 cos theta plus 1 divided by cos theta plus 1 times sine theta. Now what is sine square theta plus cos square theta? It is just 1, right? So writing that as 1, we get 1 plus 2 cos theta plus 1 divided by cos theta plus 1 times sine theta. You can see 1 plus 1 is 2, so I can write this as 2 plus 2 cos theta over cos theta plus 1 times sine theta, correct? You get the idea? Now, can you get the right hand side? You can factor 2, then you get 1 plus cos theta, which cancels, and you get 2 over sine theta, which is 2 cosecant theta, right? So let me take it on the next page. 2 plus 2 cos theta. In the numerator we have 2 plus 2 cos theta. And in the denominator we have 1 plus cos theta times sine theta, correct? So we brought forward the result. And now we can take 2 common. And so we get 1 plus cos theta. And the denominator is 1 plus cos theta times sine theta. Clearly, you can now cancel the factors 1 plus cos theta, giving you the result, which is 2 over sine theta. Now 1 over sine theta is cosecant theta, and therefore I get 2 cosecant theta as my result, which is equal to right hand side. Is that clear to you? So that is how we are going to solve this particular question. Let's look back how we did it. We began with the left hand side, taking all these terms, writing them out in the ratio of sine and cosine. Then we worked out this particular fraction, 1 plus 1 over cos theta over sine theta over cos theta cancelled, and we got cos theta plus 1 in the numerator and sine theta in the denominator. Then again, we took the common denominator and cross multiplied, getting the result sine square theta plus cos theta plus 1 whole square. Expanding and simplifying, we got 2 plus 2 cos theta, which further factoring and cancelling the factors, we simplify to the right hand side. Perfect. So that is how we actually solved all the 5 questions. I hope you understand and appreciate that. Now these are very good questions to prepare for any quiz. I hope they help you. Feel free to contact me in case you want to learn from me. Thanks for your time and all the best.